Hello everyone, this is my Coursera project. I have here this data of consumption and this is produced energy with those four features. I have copied this labels here, these features in this output for testing with manual features to test whether the predicted output is near the actual value or what value does it produce. So first of all we will train our linear regression model with these data. So in order to do that we have to first activate the add-ins for analysis toolpack here. I have already marked it as yes. I'll click OK and select data analysis, choose regression for linear regression. Here it is demanding as input y range the outcome value, which is this. I'll mark this as the output range. I'll also try to select it to the last value, which is 9569, and do it again. Now for this I'll come back to the top and choose these four as my features as input x range. I'll select labels because I have already selected labels in the data. It has changed the, I have not set it. I'll do it again. Correct. So I'll check for residuals to check what error or what is the difference between predicted and output value for the given data. It is saying that the output will try to output it into the column. I'll try to copy it somewhere here or here. This is my output range, and I click OK. It is having trouble offsetting because the input x range is again not set. I'll no. The output range is here and the input range is, let's go back to the top, selected, and rest I don't want anything. I'll click OK and you will see this is my summary where I have this. I have R square, and coming back to this sum of square, mean square, I have coefficients of ATV, AP and RH as these, and the y-intercept as 454 or the bias or W0, and I'll try to make a formula of prediction with this intercept plus this times AT value plus V times this plus AP times AP plus RH times RH, and click on OK. I don't have any values, so it will just show 454. I'll copy the values and change it a little bit. You can see that it is not showing exact value as this one. This is because of some reasons I do not know. It is not showing exact values, as maybe because this is limited to 2 points, the numbers, but here the numbers are not limited to 2 points. We can try and change that in formatting, but let's accept it for now. If you want, you can change that by, because we have copied it, right? If I manually enter values 14.96, 41.76, so actually nothing was wrong with that also. That was my fault. If I come again and remove it and just keep that, and so I'll test my model. It is saying 467, and it is same as the predicted value for the first observation, because it's just using the model. Apart from that, I wanted to tell that why did I choose this linear regression model other than any other model, is because I read through the combustion, this energy making process, the cycle, and got to know that these features are pretty much linearly, or you can say proportionally, affecting the final energy, produced energy. So it is not affecting the model as uh, as some powers or non-linear model. There is some proportionality, that's why I use linear regression. And if you check, the errors are like less than a percent, the residuals are less than a percent for each observation. So this is why it is very much accurate at like you can, if we can check for error as per the absolute error for each observation, with the residual divided by the mod of residual, the same. You can make a formula of mod of residual divided by, into 100 divided by this, and for this function too few arguments. Okay, I'll change I'll do it one by one. But it has not changed. So if it is okay, sorry, it was taking the modulus of the value. Absolute value is what I want. Absolute value of this number j 36, j 36, yeah, right. Ignore it. This is the number and this is it. And if I, sorry, my bad, the modulus was wrong. I should have used this one. And if I multiply it by 100 times, this is 0.8%. And if I do it for all, like 1%, 1%, 1%, the error is even 1 is 2.5, or otherwise it's less than 1% and somewhere 2.8. If I traverse all the way together, it is very low. So this is why I chose a linear regression model for this problem, to predict the actual energy outcome for the all four features. Thank you very much.